Hello everyone, this is Hamza Noor. Welcome to my YouTube channel. And in this particular video, I'm going to discuss the concept of marginal propensity to consume and marginal propensity to save. All right, and this is relevant for the course of mathematics for economics. So if you are studying this course, so this video will be most probably very helpful to you. All right. So first of all, before coming on to this particular example, let's have a look at some basic concepts. All right. So basically, the national income, if we assume that the national income is attributed towards two things. One thing is consumption and one thing is savings. Income is equals to consumption plus savings. All right. So basically, what we can say is that savings can be represented as a function of income, and similarly, consumption can be represented as a function of income. All right. So if we differentiate the savings with respect to income, we find that derivative of savings with respect to income, we get marginal propensity to save. And if we find the derivative of consumption with respect to income, we find the marginal propensity to consume. All right. Let's assume that we have consumption as a savings of income in this way. Consumption is equals to C naught plus C times Y. This C is a small one and this is capital one. So C naught is basically just a constant term and C naught is greater than zero. I mean, if the level of income is zero, there might be some consumption over there. I mean, you might be wondering that when the income level is zero, how will you consume when you don't have any inflow of income? So basically, you are just assuming that you are using the past savings in order to consume in the present time. So C naught is greater than zero, and this C is between zero and one. This C is between 0 and 1. This is basically the gradient of the consumption function, the gradient of the consumption function, and this C is actually the marginal propensity to consume. So if I tell you the basic definition of marginal propensity to save and marginal propensity to consume, so basically marginal propensity to consume refers to the concept that due to the rise in the fraction of income, what what fraction goes to the consumption. All right. uh, a fraction of the rise in national income which is attributed towards consumption, and the fraction of a rise in national income which is attributed towards savings is basically marginal propensity to save. So since we know that y is equals to c plus s, all right, and if we make savings the subject, I mean, if we find the savings as a function of income, what we will say is that S is equals to Y minus C. All right. And first of all, we have C is equals to C naught plus C times Y. C is equals to C naught plus C times Y. We are going to use these two types of equation in order to derive the MPS and MPC. And then we will see that what is the sum of the values of MPC and MPS, and that is equals to 1, and you will just see the proof of this thing. So if I find the derivative of consumption with respect to y, the C naught is just a constant term. When this will be differentiated, it will become 0. And when Cy will be differentiated, y is the variable over here. So this will become C. So we can say that the derivative of consumption with respect to income is equals to C, and which is basically marginal propensity to consume. The second thing is that we have savings as a function of income. So S is equals to Y minus C, and in place of C, what you can write, C naught plus CY. C naught plus CY. Okay, so if you expand this equation, savings is equals to income minus C naught minus C times income. And what we can do over here is, as we know that y is a common term, this y variable is a common term over here. So this can be rewritten like this: s is equals to taking y as common multiplied by 1 minus c and then minus c naught. So if we find the derivative of savings with respect to income over here, so ds over dy is supposed to be, this 1 minus c is a term which will obviously be a constant term, and this is being multiplied by y. We can say that the coefficient of y is actually 1 minus c. So when this thing is differentiated, all right, when this thing is differentiated, the y variable, the as you can see, the power of y variable right now is 1. When this will be differentiated, this will just become a constant term and the derivative will be 1 minus c. Okay, and this c naught, when differentiated, it will become 0. So we can say that the derivative of savings with respect to income is equals to 1 minus c, and this is actually MPS. So MPS is equals to 1 minus c, and since we know that this c is equals to MPC, therefore we have derived the equation that MPS is equals to 1 minus MPC, and therefore we can say that the sum of marginal propensity to save and marginal propensity to consume is equals to 1. All right. Basically, what is marginal propensity to save? Uh, it is, uh, as I've told earlier, that the, the rise in the fraction of income which is attributed towards saving, and NPC refers to the concept that the rise in the fraction of income which is attributed towards consumption. Now let's have a look at this example. If the consumption function is c is equals to 0.01 times y square plus 0.2 times y plus 50, calculate MPC and MPS when y is equals to 30. So here you can see that the consumption as a function of income is given in a quadratic form. This equation is quadratic. And as we saw over here that the consumption as a function of income was given as a linear equation. So the derivative was just a constant term. But in this case, the function is quadratic, so the derivative will be a linear function. All right, what we need to do is calculate MPC and MPS when y is equal to 30. Once you are able to find the value of MPC, and since you know that the sum of MPC and MPS is equals to 1, you can easily find the value of MPS as well. So consumption is equals to 0.01 times y square plus 0.2 times y and then plus 50. All right, so the derivative of consumption with respect to income will be equals to 0.01 times 2 and then y plus 0.2, and then when 50, the constant term, is differentiated, it actually becomes 0. All right, so the derivative of consumption with respect to income is supposed to be 0.02 times y plus 0.2. And as we saw earlier, that this derivative of consumption with respect to income is actually MPC. So MPC, we need to find the value of MPC at the point where the income is equal to 30. So MPC is equals to 0.02 times 30 plus 0.2. How much is the value? 0.02 times 30 plus 0.2. This is supposed to be 0.8. MPC is equals to 0.8. And since we know that the sum of MPC and MPS is equals to 1, so MPS is equals to 1 minus 0.8, and therefore MPS is equals to 0.2. So the value of MPS is 0.2 and MPC is equals to 0.8. So how we interpret this whole situation, that we are getting the MPC value as 0.8 and MPS value is 0.2. So this basically indicates that when the national income increases by 1 unit, when the national income increases by 1 unit from its current level of 30, so we can say that the consumption rises by approximately 0.8 units. Okay, whereas the savings rise by only 0.2 units, because you know that when the income is increased by 1 unit, so that one unit will attribute it in such a way that some of the portion goes to MPC, some of the portion is attributed towards consumption, and some of the portion is attributed towards saving. So that what we are talking about, the increase of one unit in the level of income, that is this one. This is the one which we are talking about. And this is equals to the sum of MPC and MPS. So we can say that at this level of income, the nation has a greater propensity to consume than it has to save, because the value of MPC is higher than MPS. There is an alternative approach to solve this, this example, in which you will find the exact value of MPC and exact value of MPS. Let's have a look at this thing. You will find the same answer, okay? MPS equals zero point 0.2 and MPC equals zero point 0.8. Let's have a look at this thing. So basically what we know is that the consumption is equals to, oh sorry, the income is equals to consumption plus savings. All right. So what we can do is that if we make savings a subject, what we will get, consumption, income minus consumption. S is equals to Y minus C. Savings is equals to income minus consumption. And what we know is that the consumption as a function of income is 0.01 times y square plus 0.2 times y plus 50. So S is equals to y minus 0.01 times y square plus 0.2 times y plus 50. Now what we are supposed to do, expand this whole equation. So S is equals to y minus 0.01 times y square minus 0.2 times y and then minus 50. Now what we can see is that this y and minus 0.2 times y can be simplified. So this is supposed to be 0.8y. S is equals to 0.8 times y minus 0.01 times y square minus 50. All right. Now, if we find the derivative of savings with respect to income, which is actually the NPS, and since we know that the savings is also a quadratic function, so the NPS, the derivative of savings with respect to income, is supposed to be a linear function. Okay. So when 0.8y is differentiated with respect to y, it becomes 0.8 minus 2 times 0.01 and then y, and then when minus 50 is differentiated, it becomes 0. So what we can say that the MPS function, which is a linear function actually, this is 0.8 minus 0.02 times y. All right. So what we need to do is find the value of MPS when the level of income is equal to 30. So MPS is equals to 0.8 minus 0.02 times of 30. So 0.8 minus 0.02 times of 30, your MPS value is equals to the same one which we found earlier, 0.2. MPS is equals to 0.2, and since we know that MPS plus MPC is equals to 1, so MPC will be equals to 0.8. So if you found this video helpful, uh, don't forget to like, share, subscribe, and until next time, see you soon.